Bruce, let me show you where we're at, what I've come up with. First of all, let me tell you that I did what you asked. I put the struts on the new motors. I've got them over here. Put the struts on the new motors, connected them to the controller at 6 volts. It did slow them down just a little bit. It also increased the current draw a little bit, so I had to make an adjustment to the current threshold. But same problem that we had before. As long as I interrupted the motion before they went all the way down or before they came all the way up, I could cycle them as many times as I wanted to. The first time I let them go all the way down and stall out on their own, they locked up, jammed up, and wouldn't come up again. So I disconnected everything. I adjusted my power supply down to 5 volts and connected everything back up. And again, as long as I interrupted the movement, we were fine. But the first time I let them go all the way down and jam on their own, not only did they jam, but they when I tried to reverse them and bring them back up again, they pulled so much current that they burned out the voltage regulator in my power supply. And that's the 3rd voltage regulator I have burned up in trying to get these cotton picking things to work. And those are 5 amp regulators. I don't know if you can see that or not, but what that tells me is that at 5 volts, when these things jam themselves and they tried to come the other way, they were pulling more than 2.5 amps from the power supply trying to get moving, and that's what burned out the voltage regulator. And that's just, there's no reason that those things ought to be pulling 2.5 amps, and so that's not the solution. So what I have done, these are 2 of the old motors, the 2 old motors that I have. These are the ones that had slop in them. These are the ones that I've been working with. And I tell you what I've done 2 things. First thing I did was put a bonded washer over the motor shaft. I took the brass slider off and put this bonded washer over the motor shaft. I don't know if you're familiar with these or not. I sell these at my hardware store. They're commonly available. It's a dome-shaped washer, what we used to call a bell washer, that has a neoprene rubber washer bonded to the back of it. I slid it over the motor shaft with the metal part out so that the brass slider would run up against it, and the shape of the washer would provide a little bit of spring action along with the neoprene back of the washer. Put everything back together, and the second thing I did was I took 2 pieces, a double layer of this double-sided foam tape, and I put underneath the thing that holds the strut. My concern is that when this brass slider comes all the way back against this back plate, there is absolutely no play whatsoever, which I'm sure is what you wanted, what you intended in your machining. But I think what it does is it causes that brass slider to be pulled up under there so tight that it just takes too much current to get it moving again in the other direction. So I've modified these 2. They've got a bonded washer on the motor shaft, and they've got that double-sided foam tape. And I'll plug them up here, and I'll show you what we got. By the way, I'm back on 7.2 volts. And as you can see, they're coming all the way up. They stall. They are tight. There's no play in them. I don't think any modeler in his right mind would have any problem with that. That's not going to flop. That's not going to rattle. That's not going to cause whatever motion you're seeing there is because of motion on the board that's clamped to the bench there. But the mechanism is not moving at all. And before I made this movie, I cycled these things I don't know how many times. The H bridges are not being overloaded, the circuit's not being overloaded, the battery's not being overloaded, the motors are not hot, there's no problem, everything is working just the way it ought to. I'm telling you, there's something about the way that slider comes up under those two little arms these motors are so powerful that if it is allowed to come all the way up, it's pinching. It's just so dadgum tight that they won't move the other way. And that's the only modification I made to them, is just to give a little bit of relief, so that there's something softer for it to stall out against. And these are the old sloppy ones. I haven't tried it with the new ones yet. It's already 7:15, and I've been on this working with these others all afternoon. But I mean, I think this should tell you we're back on 7.2 volts. We're back with fast moving motors. I think if we were to drop this down to 6 volts, it would be even better. But I mean, you couldn't ask for anything to work any better than that's working. And it's because instead of going about it with a eye toward a change in the voltage or whatever, my focus here was a change in that mechanism. I was convinced that mechanism was jamming, and I'm even more convinced of it now. If you want me to, at some point next week, I'll put another regulator in my 6-volt power supply, and I'll drop it down to 6 volts, and I'll check it if you want to do that. But I probably need to spend my time next week working on the units that you have already sold that you need me to build. But I'm telling you, Bruce, we've been barking up the wrong tree. The problem here is in that mechanism. It's pulling that slider too tight up in there, and it's just jamming it all up. If you want me to send you these so you can break them down and look at them and see what I did to them and see the changes that I made, so that you can have some idea what direction to go, be glad to do it. But that's where we stand as of right now.